The mathematics of counting is a branch of mathematics called combinatorics, and there are a few concepts from combinatorics that are very useful and may come up in your exams. The first one we're going to look at is factorial. Now, factorial has a special symbol. It's an exclamation mark. Anytime in math you come across some new symbol, it's a little bit daunting, but it turns out this is actually really simple concept. So all factorial means, and the way you read the left column is 1 factorial when you see the exclamation mark, is it's the product of all the natural numbers less than or equal to the number before the exclamation mark. So 1 factorial is just 1. 2 factorial is 2 times 1, which is 2. 3 factorial is just 3 times 2 times 1, which is 6, etc. And you can see that these numbers get big pretty quickly, right? 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. 6 factorial, after you've done this for a little bit, you realize you don't really need to multiply all the numbers because you've already multiplied all the numbers but 1 in the previous row. So 6 factorial is really just 6 times 5 factorial. And we know what 5 factorial is. It's 120. So 6 factorial is 720. 7 factorial is just 7 times the previous number, 6 factorial, which is 5040. 8 factorial is 8 times 5040, so 40,320. 9 factorial is 362,880. And 10 factorial, we just have to add a 0 to that. That's pretty easy. 3,628,800. And it goes on, and as I said, they get very big very quickly. Now, before I really get into what these things are good for, let's just take a look at a little bit of arithmetic using factorials. Let's say you want to do a division, 5 factorial divided by 3 factorial. Well, you don't need to actually work out what 5 factorial is and what 3 factorial is and then do the division. All you have to do is realize that if you have 5 factorial, that's 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. So there's always going to be this matchup which will allow you to cancel out many of the factors. And so all you're left with is 5 times 4, which is 20. Now this is actually going to become particularly useful in a later lesson on combinatorics. 20 factorial over 19 factorial. Here these numbers are so big they would take you quite a long time to calculate and to write out. But there's no need to, because again, 20 factorial is just 20 times 19 factorial. And so the 19 factorials just disappear, and you're left with 20. So what is this good for? Turns out that this will help you answer questions that involve ordering. So ordering a certain number of objects. So here's a typical question. You want to take a picture of 4 people. In how many ways can they sit in 4 chairs? So you want each of them to sit in one of the chairs. How many different rearrangements are there? How many different pictures can you take? Now, I've got 4 boxes here. This is a pretty standard technique for figuring out these problems, sometimes called a pigeonhole technique. And here's the way to think about it. Let's say nobody is sitting yet. So you've got 1 seat on the left. 1 of 4 people can sit in that seat. So there are 4 possibilities for that first seat. Now, once you have 1 person sitting, there are 3 people still standing. And so therefore, you've got to pick one of those 3 to sit down in the second chair. And now there are only 2 people standing, and so you've got to pick one of the 2. There are 2 ways you can pick one of those 2 people. And once you've got 3 people sitting, there's really only 1 possibility for that 4th. And these numbers multiply to give you 4 factorial, which in this case is 24. So there are 24 different pictures you can take. Now, if you're dubious, if you don't really think this technique is actually capturing reality, you can, of course, list out all the possibilities. So let's say we have the people with their initials, A, B, C, and D. Now, when you go to list out possibilities like this, for starters, it takes time, and you don't really want to be doing this in a test or exam situation. And it also helps if you've had a lot of practice doing this so that you can do it in a very systematic and orderly way. Otherwise, you're not going to be sure that you've actually captured all the possibilities. So if you notice, the first 6 all start with A. The next 6 all start with B, the next 6 with C, the last 6 with D. Also, if you notice, the second column is always going in order. B, 2 B's, 2 C's, 2 D's. All right, and then once you've got 2 of them down, let's say the first one there, A, B, C, D. All right, once you've got A and B seated, as it were, you've got 2 people left, C and D. And there's obviously just 2 ways you can order those 2 people. And that pattern continues all the way down, right? There's always just 2 ways of ordering 2 people. Here we're ordering B and D 2 different ways. Here we're ordering B and C 2 different ways, etc. And that repeats throughout. With 3 people, there are 6 ways, right? The first column, if you just eliminated A entirely and we're taking a picture of just B, C, and D, well, if you just eliminate that first column, you've got all the different ways of ordering B, C, and D, the 6 different ways. And 3 factorial is 6. So if we go back up to the list here, you can see that the number of possible pictures is going to be huge if you've got a lot of people in the picture. If you have 6 people, you've now got 720 different possibilities. So this kind of question could be ordering people sitting at a table, or ordering books on a shelf. Right? If you've got 7 books, how many ways can you put them up on the shelf? Well, 7 factorial, 5,040. So a lot of times you don't need to calculate these numbers, but you do need to be able to recognize them. And you do need to be able to know what the symbol means. And don't be too alarmed when you see new symbols like this. Oftentimes they really represent something quite simple.